Hai, Assalamualaikum warahmatullahi wabarakatuh. And good day to all the students. I'm Dr. Siti Rabiatul Aisyah binti Idris, and welcome to DMM1523 or DRM1213 Engineering Materials. Today we are going to look at on Introduction to Material Science and Engineering. As for the chapter objectives, it started with number 1, explain and discuss the material science and engineering materials. Number 2, understand the relationship between structure, properties, processing method, and performance of the materials. Number 3, differentiates the types of engineering materials and give examples on their current and future application. And number 4, material selection and design for sustainability. Whereas for the lesson objective, students should be able to analyze and illustrate the materials, atomic bonding, and crystal structure. Well, basically, for lesson objective, it covers several topics, which is chapter 1 and chapter 2 for this case. And move on to topic content. We are going to look at on Introduction to Material Science and Engineering. Number 2, classification of engineering materials. After that, we are going to continue our lecture with the new topic, which is chapter 2. In material science and engineering, it is actually emphasized the understanding how the history of a material, which is processing, influences its structure and thus the material's properties and performance. Material science and engineering is also an important part of forensic engineering and failure analysis. For example, investigating materials, products, structures, or components which fail or do not function as intended, and finally causing personal injury or damage to the property. Such investigations are key to understanding, for example, the causes of various aviation accidents and incidents. But okay, first of all, let's look at the evolution of the materials itself. It starts with the Stone Age. For example, stone, wood, clay, and these materials exist in nature. After that, moving to the Bronze Age, for example, alloy and copper, followed by Iron Age. During that time, it was known as Industrial Revolution, followed by Electric Age, and until now, nanomaterials age. And as mentioned to you in the previous lecture, there are relation between material science, materials engineering, and material science and engineering, whereby material science is actually focusing on basic knowledge of materials, and materials engineering is actually applied knowledge of the materials, and therefore it comes into material science and engineering, which things that you are going to learn in this subject. Why do we need to study material science and engineering? This one is very important for us so that we can select the materials for a given use based on considerations of cost and performance. Number 2 is to understand the limits of materials and the change of their properties with use. And number 3 is to be able to create a new material that will have some desirable properties. So in general, all engineering disciplines should know the basic knowledge of engineering materials. Different types of materials have different structure of materials at the atomic level or microscopic level. Atomic level refers to arrangement of atoms in different ways, whereas microscopic levels refers to arrangement of small grains of materials that can be identified by microscopy. For example, carbon atoms or aluminum oxide structure like single crystal, polycrystal, and so on and so forth. Other than that, we need to understand the properties of the materials. For example, mechanical, electrical, magnetic, thermal, optical, and chemical stability. So these properties are very important for us to understand, and different types of materials have different types of properties, and therefore we need to understand in order to produce a good final product. Structure, properties, and processing has its own relationship whereby it starts with processing. Number 2, followed by structure, and number 3, properties, and finally, we may look at the performance of the materials. If you refer to this figure here, the illustration, well, material science engineering focusing on processing and performance. For the material science, only focus on structure and properties. But for material science and engineering, we use all these 4 elements in order to look at the final performance of the product. Okay, let's take the example of cake making. By introducing all those steps just now, processing, structure, properties, and performance. Okay, for cake making, we know that we do need sugar, flour, and so on and so forth in order to bake cake. So the process of mixing the ingredients is called as processing. After that, we'll get the texture, whether it is smooth or the other way around. That one is called as a structure. And then the properties, whether it is dense, packed, or hard, that is properties. And finally, this cake will have its own performance, or also known as taste, whether it is good in taste or the other way around. Number 2. Aside from mixing the ingredient, the other part of processing method for cake making is introducing it to heat. So if the heat, if the cake being exposed to not enough heating, so the cake will be liquid-like, or if the temperature is too high, it will become hard or turn out to be a biscuit. So that one is called as a structure. Dense, or as for the properties, it's either become dense or hard or too soft. That is called properties. And finally, the performance comes to the taste, whether it is good or not good in taste. So this is also a summarize for the process just now, but for the industrial application. And engineering materials have its own classification for different types of materials. For example, metal alloy classified as crystalline materials with metallic bonding. These types of classification we are going to learn it in detail in the next chapter, which is chapter 2. Number 2 is ceramic, which is crystalline materials with ionic bonding. Glass, non-crystalline materials with ionic bonding. Polymers, non-crystalline materials with covalent bonding. Composite is a mixture of the above materials. And then semiconductor. Semiconductor is a unique electrical conducting behavior, and you see the most common materials, engineering materials that being used in the market or in the industry nowadays include such as metal and alloy, ceramic, polymers, and composite. As for the application, well, in any types of product, normally we don't use only one types of materials in order to come out with a final product. For example, in this case, it's a vehicle or car. A car consists of aluminium, plastic, ferrous metal, and so on and so forth. So we need to understand that to produce a good product, a good final product, it needs to combine several types of materials with certain types of percentage that is required. Okay, now let's look at one by one for each types of materials, starting with metals and alloy. Metals and alloys is actually inorganic substances which compose one or two metallic elements and also contain non-metallic elements. The properties for metals and alloy are crystalline structure, good thermal and and electrical conductors, strong and ductile at room temperature, good strength at high temperature, shiny when polished. And for metal and alloys, it is classified as ferrous metal and non-ferrous. Ferrous is, for example, steel, cast iron. Non-ferrous, those who are not in phase diagram. For phase diagram, you're going to learn in the next topic, which is chapter 3 or 4. Okay. Example like iron, copper, aluminum, nickel, titanium for metallic elements, and carbon, nitrogen, oxygen for non-metallic elements. Okay, if you refer to this periodic table, those elements that are inherently metallic in nature are shown in color, blue color there. Application includes automobiles, structures, airplanes, trains, machine tools, electrical wiring, and so on and so forth. So basically, these are the only example, and you may find more application in the market out there. Number 2 is ceramic and glass. Ceramic and glass is an inorganic substances whereby it consists of metallic elements and non-metallic elements chemically bonded. There are usually combination of metals or semiconductor with oxygen, nitrogen, or carbon. Its properties include crystalline, non-crystalline, or mixture of both. It can be either one, with high hardness, high temperature strength, brittle, lightweight, high strength, good heat and wear resistant, reduced friction, insulative properties. And if you look at this periodic table, ceramic compounds indicated by combination of one or more metallic element in light color with one or more non-metallic elements which is in dark in color. The applications includes electrical insulator, abrasive, toilet equipment, pipe insulator, pottery, and so on and so forth. Number 3 is polymeric materials, whereby it consists of organic long molecular chains or network. Its properties include most are crystalline, some are mixed, very strength and ductility, poor conductors of electricity, good insulator, low density, low softening temperature. And polymers can be divided into 2, which is plastic. It's also known as hard in properties, and also elastomer, which is a little bit softer than the plastic. In plastic, there are 2 types of plastic, which is thermoplastic and thermoset. You see, plastic is the other name for polymers, yeah, because of their extensive formability during fabrication, and there are synthetic, which is human-made materials, which represent a special branch of organic chemistry. And polymer is very attractive with its lightweight and low cost. Predictable with elements associated with commercial polymers in color. The one with the blue color there is classified as polymer materials. Example of application includes packaging, containers, adhesive, roofing panel, construction, electronic, and so on and so forth. Number 4 is composite. Composite is a material which is made up of 2 or more distinct materials, normally matrix and reinforcement. The properties includes combination of properties that is not displayed by any single material. So it is actually a combination of properties by several materials. And the reinforcement is usually stiffer than the matrix, thus stiffening the composite materials. Example of product like composite, concrete or fiberglass, yeah. And for composite, there are types of composite that can be found in the market like PMC, MMC, and CMC. All right. Example of applications include glass fiber, F1 sports car, which use carbon fiber, helicopter rotor, and so on and so forth. Yeah. Other than that, it is also can be part of the total component. For example, several parts in cars or several parts in aeroplane. Last but not least is electronic materials, which is semiconductor. It has unique properties capable to electrical conductivities in their surface chemistries in very localized area. And the conductivity is as good as metals because no free electron and the electron valence is full. We will learn on electron valence in detail in chapter 2. Periodic table, the elemental semiconductors in dark color, and those elements that form semiconducting components are in light color. The semiconductor components are composed of pairs of elements from columns 3 and 4 and 5, or from columns 2 and 6. In terms of material strengths, different types of materials obviously may have different in strength. For example, in this case, if you refer to this figure here, metal and alloys can provide or give the highest strength as compared to polymer, ceramic, and also composite. So you may imagine how expensive these types of material can be because of its properties. Other than that, you can see the engineering materials production from this graph. So over the years, the production of the materials keep increasing. And if you look at here, the most consistent material is steel, and polymers actually keep increasing from year to year. Same goes to this table, this figure. You can see that the most used materials were steels compared to iron, plastic, and aluminium. In terms of cost, you see different, even though there are different types of materials, even though different types of materials have different types of cost, the process method for that materials may also affecting the total cost of that materials. Yeah, for example, aluminum ingot, engineering plastic, or steel hot rolled. See, steel hot rolled compared to steel cold rolled. Steel hot rolled is much more cheaper as compared to cold rolling. So that is referred to the process method for that materials. Okay, so basically the material selection process start with pick the application. Then we need to determine the required properties like mechanical, electrical, thermal, magnetic, optical, or deteriorative. Number 2, it's properties, whereby we need to identify the candidates like structure, the composition, and then the materials. We need to identify the required processing. For example, whether we want to use casting, sintering, vapor deposition, and so on and so forth, whereby this process may change the structure and the overall shape of the materials. So select the right materials to produce the final product. As for the summary, use the right material for the job, understand the relation between property, structure, performance, and processing. And number 3, recognize new opportunities offered by material selection. With that, I thank you very much for your kind attention. And that will be the end of chapter 1. So by next week, we are going to look at a new chapter, which is chapter 2, which covers the atomic bonding and structure. With that, thank you very much. See you again next week, and bye-bye.